All right, so in this video, we're going to be looking at rigid motions with parallel lines. So far in the class, we looked at rigid motions with shapes, right? We had rectangles, triangles, diamonds. We were translating, rotating, reflecting all of those shapes, and we saw that the measure of the angles didn't change, the length of the line segments didn't change. So now, instead of doing it with the shapes, we're going to be using parallel lines. So let's go ahead and start off with some definitions about parallel lines and lines in general for pre-algebra. So we're going to define a line. All right, so definition. A line is a continuous straight curve with no thickness and an indefinite length. So let's break up this definition to see what it means. It says a line is a continuous straight curve. What do we mean by continuous? Continuous just means we're not going to be picking up our pencil and jumping around, finishing the lines, okay? So this is not a line. This is not a line because there's a gap. We're not going to be jumping around making lines. All right, so the continuous part means this is what one of our lines is going to look like. Line. All right, continuous, straight. Straight curve because for pre-algebra, we're going to assume all of the lines that were given on quizzes and tests and in these videos, we're going to assume that these lines are straight lines. All right, so no curving lines. This will not be one of our lines for pre-algebra, okay? So now we can look at where it says we have no thickness, okay? So what does it mean by no thickness? No thickness, we're just gonna assume that this line right here, try to imagine this line as being indefinitely thin, okay? Infinitely thin. So we're just gonna be, so try to think of it as not having thickness at all right? You could just try to imagine that. And an indefinite length. So when I say indefinite length, that just means that we don't know, we're not worried about how long it is, and we're also not even given that, okay? So let's say we're not even given the length of the line, we just know it's a straight, continuous straight curve with no thickness. So indefinite just means we don't know how long the line is. All right, so this is what our lines are gonna be looking like in pre-algebra. So now we can go on to the next definition. The next definition says parallel, okay? So we're gonna define parallel, what it means to be parallel. A line is said to be parallel, that's P-A-R-A-L-L-E-L. A line is said to be parallel to another line if the lines do not intersect. They never cross. So all that means is that if we have two lines and they never cross, and normally we're gonna be given that information. So they're gonna tell us these lines are parallel. All right, so when they say that, that means that we're gonna know that means that those lines do not intersect. They never cross. So now so for example, these pens. These pens are parallel because if you extend these pens in either direction, then you'll have that these lines go on forever, right? You can kind of see it. All right, so now we can go on to here and let's look at some examples for translating, rotating, and reflecting parallel lines. So let's say we have this parallel line, or let's say we have this line, and let's say this line is parallel to that line. So let's start off with translations. All right, so what does translations mean? Translating parallel lines just means we're gonna be sliding the lines. And when we slide the lines, we're gonna slide both of the lines at the same time, not one at a time. We're not gonna be doing this, okay? We're gonna be doing both of the lines. So let's go ahead and translate these lines to the right. Let's see what happens. So we get these lines. Are these lines parallel to each other? Yes. All right, we didn't flip around just one. We didn't slide just one of them. They stayed parallel. All right, let's see what happens if I translate down. Still parallel? Yes, they're still parallel. We're not changing the direction of one. We're just changing the position of both. And if they're both pointing in the same direction, and I just move them down a little bit, they're still both going to be pointing in the same direction. So we can translate left, still parallel, and we could translate up, still parallel. All right, so the translation one is pretty straightforward. If you slide parallel lines, if you translate parallel lines in any direction, however many times, they're still going to be parallel. So if parallel lines are translated, are they still parallel? Answer, yes. So now we can look at the next one. The next one says, if parallel lines are rotated, are they still parallel? Let's check. So we'll start with these lines right here. Maybe we'll rotate these lines clockwise 90 degrees, so they'll look like this about the origin. All right, so that means we're going around the point 0, 0, around the origin. What happens when I rotate 90 degrees clockwise? Still parallel? Yes. What if I do it again, 90 degrees clockwise about the origin? That means we're moving around this point. So if I do it 90 degrees, they'll look like this. Are they still parallel? Yes, they're still parallel. All right, so and it's gonna be like that for the next case, right? If I rotate 90 degrees clockwise again, what happens? Still parallel? Yeah, they're still parallel because we're grabbing both of them. Okay, rigid motions, all right? So same thing that we did with the shapes, but now we're just doing it with parallel lines, all right? So if parallel lines are rotated, are they still parallel? Yes, right? We could rotate back up too, 90 degrees clockwise, all right? So that's still parallel. We could go 90 degrees counterclockwise like this about the origin. Then they look like that again, counterclockwise. All right, so that's just it for rotations, all right? It's still parallel. Let's look at this last one. The last one says reflected. If parallel lines are reflected, are they still parallel? Well, let's check. What happens if I reflect these lines across the y-axis? All right, across this y-axis, that means we're gonna be mirroring a mirror of these lines across the y-axis. So it'll look like this. It'll be like a flip. It'll look like a flip like that. And this one will be flipped like this. All right, and look at there. Okay, so are they parallel still? When we reflected, yes, they're still parallel. What happens if I reflect these over the x-axis? What happens if I mirror these over the x? Well, it'll look like this. This one will be flipped over like this. This one flipped over like this. Still parallel? Yeah, still parallel. All right, so that's it that's pretty much reflections. So we could reflect again if we wanted to, like this, reflect across the y-axis. So it would look like this. All right, so it would look just like this. So we'd reflect across the y-axis, and that's a reflection across the y-axis. Are they still parallel? Yeah, they're still parallel, right? We're not changing the direction or anything. We're not doing anything weird. We're just rigid transformations. All right, rigid transformations are very nice. All right, if parallel lines are reflected, are they still parallel? Yes. All right, so in the upcoming videos, we're just going to be doing some more examples of just mixing it up and just trying to make it sound complicated when it really isn't, okay? It's more conceptual. So for example, it'll be like, if I translate these parallel lines, 50 units right, 100 units up, 75 units to the left, reflect them over the x-axis, so like this. So it'll look like this, reflect over the x-axis, okay? Reflect over the x-axis, so they'll look like that. And then rotate 90 degrees, let's say counterclockwise about the origin. Are they still parallel? Yeah, they're still parallel. All right, because the most important thing to notice is this: translations, rotations, reflections for parallel lines. Everything gets preserved. All right, so that's pretty much gonna be it for parallel lines. We'll look at some more examples in the next videos. Let's review these definitions real quick. We said a line is a continuous, straight curve. All of the lines are going to be straight in this class. Continuous, no jumping. Okay, this is not a line. No thickness, so try to imagine this as being infinitely thin. All right, and an indefinite length, so that just means that we're not going to be worrying about the length of the lines, and most of the time you're not even going to be given the length. Okay, so that they're not going to tell you the line is 100 meters. They're just going to say here's a line. Okay, and here's some rotations, some translations. Choose the right answer. And then we define parallel, which I think you guys encountered some point, maybe in your previous math class. If not, it's okay. It just means that two lines are parallel if they do not intersect, they never cross. All right, so for example, this is not parallel because if you extended this, they would eventually cross, right? They would eventually intersect right here, all right? So this is just gonna mean parallel. All right, that's pretty much it. We're gonna do some more practice problems in the next upcoming videos. So I'll see you guys there. Thanks for watching.